This is the 2023 Thinking Skills paper. Now, I've had a chance to look through the paper, and I would honestly say it's not really one of the hardest papers I've seen. In general, most of the tests we've seen in the last few years have been roughly this level of difficulty, and I would say pretty much all the questions in this paper are perfectly solvable without with not a large amount of outside knowledge. So while you guys listen along, what I'm going to be doing is, as I explain each question, I'll be basically going through my thought process, like how I break down the questions, how I understand what's being asked of me, and how that translates to actually solving the questions themselves. Like we said earlier, if at any point you have any questions, please just use the Q&A function and one of us will get back to you. Okay, so in that case, let's get started with question number 1. So we are starting off with question 1. Inji and Finn first met on a Tuesday. They met again 8 days later. They then met for the third time 4 days later. On which day did Inga and Finn meet for the third time? So we are told that we have 2 people who met on 3 different occasions. We know the first day is a Tuesday. Now, with any kind of question that involves like calendar days like Monday, Tuesday, Wednesday, Thursday, etc., it's generally a really good idea to have it written down on paper. So what I'll start off with is actually write out Tuesday. Actually, I might just write out choose to keep it shorter. And this is going to be their first meeting. Change the pen color. So here, from this part right here, we know the first meeting is on a Tuesday. Now, we are told they met again for the second time 8 days later. Now, when it comes to calendar days, again, it's absolutely fine if you guys are comfortable with just counting the days. So you can go Tuesday, goes Wednesday, Thursday, Friday, 8 days, etc. What I like to do is, while that works for the shorter period, so 8 days, not a very long time, it's very easy to count 8 days from any given day. But what if they give you a question with like 30 days or 28 days? In cases like that, because of questions like that, and because they exist, what I like to do is I like to break down the days into weeks plus a remaining number of days. So for example, 8 days is the same as saying 7 days plus 1 day. We know 7 days is a week, and as everyone knows, if a week passes, it's the same day. So 1 week after Tuesday is still Tuesday. So if I add 7 days onto Tuesday, we know it's still going to be Tuesday. And then if I add the remaining 1 day, it is now going to be Wednesday. So we know the second meeting, which is 8 days later, is now on a Wednesday. For the third meeting, which is what we're looking at in the question, it is 4 days after that. So from here, all we have to do is count. So it goes Wednesday, Thursday, Friday, Saturday, and then Sunday. So from that, we know the third meeting will be a Sunday, and the answer will therefore be D. Let's now move on to question number 2. I'll quickly get rid of all this. So like Bruce mentioned earlier, if at any point you guys feel like, I'm going a little bit too fast and you might have missed a bit of explanation, just let one of us know in the Q&A function. And at the end, we'll start going through questions that maybe people want to have a repeat of. So question number 2. After school, Cecilia likes to visit her favorite juice stand to buy a drink. The stand sells 4 types of juice, which are available on different days. So as shown in the table, lemon is only sold on Mondays and Wednesdays, orange on Tuesday, Wednesday, Thursday, apple Thursday and Friday, and grape Monday, Tuesday, and Friday. Cecilia does not like apple or orange juice, but she will visit the stand as long as she can buy a drink that she likes. Now, because of the last sentence, what we learn is that Cecilia is only really visiting the stand to buy the juice that she likes. And obviously she's going to avoid the juice she doesn't like. What that tells us is we can immediately eliminate the juices she doesn't like. Now, we're told apple and orange are both juices she doesn't really like, so we can immediately, kind of move past that. So lemon and grape is obviously going to be the day that she wants to visit, right? So following that train of thought, we'd be focusing on these 2. However, the question itself at the end says, which day will Cecilia not visit the juice stand? Now, with questions like this, what I generally recommend is to start off by reading that last sentence first. The reason behind that is because what that last sentence does is it gives us, a clue of what exactly to look at. So when I started going through the information in this table, I started off looking at lemon and grape. What I learned from reading the actual question is that it's actually the opposite. I don't care about the juices she likes. I only care about the juices she doesn't like, which means I'm going to focus on days where it's not available. So Monday and Wednesday, we know that lemon is available. Monday, Tuesday, and Friday, we know that grape is available. So if you write out the days it's available, Monday, Tuesday, because that's when grape's available, Wednesday for lemon, and then Friday for grape again. These are going to be the days that her favorite juices are available. Now, in order for us to answer the question when she will not visit the juice stand, we know that she will visit the juice stand on these days, meaning that we are looking for days that are not in this list. So if we have Monday, Tuesday, Wednesday, Friday as days that she will visit, the days that she won't visit are simply the leftover days, which is just going to be Thursday, because Thursday is missing from that list. Okay, let us move on and we'll take a look at question number 3. So question number 3 is one of the strengthening and weakening questions, or as we call it, assessing the impact of additional evidence. The idea is you're given some sort of paragraph involving a claim or an argument and some reasoning behind it. Our job as people taking the test is to figure out which of our options, A, B, C, or D, best strengthen or best weaken that claim. Now, Nick wants to learn to speak the Wiradjuri language, but he thinks it will take him a long time. Medika suggests a solution. You should spend some time in Wagga Wagga. There are plenty of people there who can speak Wiradjuri. The very first thing we have to do for any question that involves supporting or, weakening a claim is firstly, identify what the main claim is. Now, in this case, we are looking specifically at Medika's claim. So we have to think about what is Medika saying. To figure out what a claim is, essentially what you're doing is you're asking yourself yourself the question, what are they trying to make me or someone do? In this case, Medika is trying to make Nick spend time in Wagga Wagga. Her claim is that Nick should go to Wagga Wagga, and the reason behind that is because she thinks, obviously, it will help him speak the Wiradjuri language. So now that we've identified what the main claim is, we now have to figure out what, I guess, is the context behind it. What is the main topic we're looking at, or the theme, I guess. To do that, we have to first figure out what the most important part of the paragraph is. Now, if Nick is trying to learn a language, we have to figure out what is Nick talking about in terms of the language? Is he talking about, how hard it is to speak? Is he talking about how, I guess, not many people speak it? It's none of those things. We have to read the paragraph, figure out what specifically he's saying about learning the language. In this case, we see he thinks it will take him a long time. And we know that Medika is now suggesting a solution. So we know Medika's claim is all about how to mitigate, or I guess shorten, the amount of time it takes Nick to learn the language. In other words, how to make learning the language easier. So we know the claim is making learning the language easier. And our reasoning is that there are plenty of people who can speak Wiradjuri. Now, what Medika is doing is she's connecting the idea of being around a lot of people who speak a language, and that, I guess, talking about the idea that how that would help actually learn the language as well. So spending a lot of time around people who speak a certain language will allow you to absorb that information and speak it, or learn to speak it easier. So knowing those, now we look at the options. So A says Nick can travel to Wagga Wagga fairly easily. Now, when you're assessing the options to figure out which one is correct, which one is incorrect, essentially there are three categories option can fall into. The first category is obviously supporting the claim, which is the option we're looking for. The second category is weakening the claim. Does it actually say something that directly contradicts what's being said in the paragraph? The third category is being irrelevant, where it doesn't really affect anything in the paragraph. Now, we know from our analysis of what's been said that essentially Nick is trying to find a way to learn a language easier, and Medika is saying that spending time in Wagga Wagga will do that. It's all about how it impacts his ability to learn the language. Now, A says Nick can travel to Wagga Wagga fairly easily. Keep in mind, this is talking about traveling to Wagga Wagga. You have to ask yourself, is the travel time really important in terms of how it affects your learning? And obviously the answer is not really. It doesn't matter how far you travel, that's not going to make a difference on whether it has a good or a bad impact on your learning ability. So A is definitely wrong because it is irrelevant. B says learning a language always takes hard work and concentration. Now, this is simply defining what learning a language consists of, what is, I guess, important when it comes to learning a language. Now, while that is about learning, is it about specifically what Nick is talking about? Because Nick, in this case, is talking about time, how long it takes him to learn the language. Since B doesn't talk about the time it takes, we know B is incorrect as well. Now, C says Medika has learned to speak 3 different languages. Now, C is a bit of an interesting one because it does talk about the idea of learning languages, and it talks about Medika instead. Now, what C does is it shows that since Medika has learned to speak 3 different languages, what it's trying to do is show that Medika has something called credibility. The idea that because she learned a lot of languages, you can trust her. However, while that does sound like it is supporting the claim, the issue with C is that at no point does it say anything about how, I guess, knowing 3 languages makes you correct in learning, if that makes sense. The idea that just because Medika knows 3 languages, that doesn't mean that she knows how, I guess, Nick will learn better if he goes somewhere, or how her methods will impact Nick. Because C doesn't actually have the impact on Nick himself, and keep in mind, Nick's the one doing the learning in this case, C is not quite relevant either. And that leaves D as our correct answer. Languages are easy to learn if you practice speaking them with other people. The reason why D is correct is because, number one, it's the most relevant. It talks about the idea of speaking languages with other people, and we know that's the whole point of going to Wagga Wagga, because a lot of people there speak Wiradjuri, the language Nick is trying to learn. That's point number one. Point number 2 is obviously the idea that it makes it easier, which is what Medika has been trying to say the whole time, that go to Wagga Wagga because it will make the language easier. Since D is both supporting and is the most relevant, it is the correct answer. All right, let's move on to question number 4 now. Once I quickly get rid of this, there we go. Okay. The wooden puzzle below fits together to make a cube. Pairs of blocks will fit to make 1 of 3 layers, which will complete the cube. Now, obviously, just from looking at it, we know that some of these parts essentially are meant to fit together. So this part is meant, like all these little edges here and there are meant to fit together with the edges and lines in the first row. So first thing I'll do is separate the rows. We know that, actually, sorry, not separate the rows. The idea is, what I'm going to do is focus on one block at a time and compare them to the other blocks to see which ones fit together. Now, obviously, that's probably what everyone is going to plan to do in the first place. But the question is, how do we actually make that easier for ourselves? Now, with a lot of shapes, especially ones like 2, which have a lot of these parts going up, going out, a lot of these corners, stuff like that, we have a lot to look at. The question then becomes, to solve this within the time given to us in the OC exam, how do we do it efficiently? So my general approach is to always focus on one specific prominent feature, the feature something that is a bit unique. So something that maybe sticks out a lot, or something that you look at and be like, okay, this looks like it's unique to this shape and not to anyone else. else. So for example, if you look at shape number 1, I can straight away see this little, I guess, divot in shape number 1. What that tells me is that in order for a block to fit nicely with shape number 1, there needs to be a big, flat, I guess, rectangular prism-like, I guess, feature sticking out of one of the blocks. So first things first, I'm going to look through the options to figure out which of these has that very wide, I guess, feature. So we know 2 straight away cannot mix with 1 because 2 doesn't have any wide, I guess, or the wide protrusions. So we can get rid of 2. 3 has this pit here, so we'll keep that in mind. 4, again, same reason as 2, doesn't have any of the wide protrusions. We can get rid of 4, same with 5, and 6 also has a wide protrusion here. So straight away, we've already narrowed down 1 being in a pair with either 3 or 6, so we don't have to worry about 2, 4, or 5 for the moment. Once you've narrowed down your choices, the next thing to do is, once you've identified your prominent feature you want to look at, the first thing you look at is going to be that feature. The second thing is, what is directly next to that feature? So in 1, we can see that there was that wide, I guess, hole there, but right next to it, the only thing that occurs next to it are 2 flat areas, which means there must be areas for these 2 flat parts. So something a little bit wide and something narrow and nothing else. Now that lets us eliminate 3. The reason behind that is because 3 actually has many more corners, whereas here we're only looking at 2. So there's clearly not any place that the parts in 1 can fit into 3, leaving us with 6 is the answer. And more specifically, we can see that the thin part here connects to this part here, and the wider part here connects to this part here. So 1 and 6 must be a pair. And the great thing about multiple choice is we can quickly scan through the options and notice that only 2 options have 1 and 6 as the possible pairing. We can get rid of everything else. Now, when you're tossing up between 2 options, so the natural, I guess, instinct for a lot of students is to straight away start testing the next thing. So I just got to note that the running writing makes it a bit hard to read. Well, I'll just quickly change the block writing so everyone can read it a little bit easier. Sorry about that. So like I was saying, what you want to do is compare the 2 options you have left directly. Now, what we can see is straight away, option B and D both have 1 and 6 as the first pair, which we know is correct. Option B has 2 and 5 for the second pair, and option D has 2 and 3 for the second pair, which means the only thing we have to do is actually compare one of those options. So if 2 and 5, if we check 2 and 5 and that doesn't work, we can get rid of it, which means D is the answer. If we check 2 and 3 doesn't work, we can get rid of that and we can put B as the answer. So I'm going to start off by checking, B is first, so we'll check 2 and 5. So I'll quickly get rid of the notes I've made for the rest of them, and we'll focus solely on blocks 2 and 5, which were outlined in option B. So following the same strategy we used for the first pair, the first thing we're going to do is figure out what is the most prominent feature. So if you look at 5, we can see 5 has this one bit sticking out much further than the rest, which means there must be some sort of divot. Now, the 2 options we had were 2 and 5 or 3 and 5. If you look at 3, is there any part in 3 where this long protrusion can fit into? Not really. The only part they have that's kind of in the middle would be this part here. And we can see that it's far too short fit in this part here. Whereas in 2, we have this area right here, which is deep enough to accommodate our feature. Now, just from that, we actually know the answer is B straight away because we've proven that 3 doesn't fit with 2. Because of that, what we can now do is just check the areas around it. So if we're looking at this part in 5 and that fits into this part of 2, what about the parts around it? So let's quickly get rid of the circle so we can see everything a little more clearly. We are now going to focus on this part over here. And we can see this makes a kind of a staircase pattern. And we can see a similar staircase pattern here, which means this part will fit in with this part. In the same deal, we can see a smaller staircase pattern with only 2 parts instead of 3 steps, which will fit in with these 2 steps here, meaning that everything in in shape 2 fits with shape 5, meaning that shape 2 and 5 is the second pair. Therefore, the answer is indeed B. Alrighty, let's move on to question number 5 now. Let's take a look. So Simon is watching a news report which claims that nearly a third of Australians go swimming regularly. Simon says, upon hearing this, that can't be true. I almost never go swimming and neither do any of my friends. We are asked to find which of the following sentences shows that Simon has made a mistake. So questions like this are very similar to what we talked about earlier in terms of like strengthening, weakening. The idea is, I guess the main topic behind this is called identifying reasoning errors, finding the part where Simon has made a mistake. Now, to do that, first thing I have to do is quickly break down what is said in the quoted statement or the box over here. The very first thing I notice is that he's watching a news report which claims that nearly a third of Australians go swimming regularly. So we're not talking about 1/3 of Australians. So straight away we know that 1/3 means it's not everyone, okay? So if only 1/3 of Australians go swimming, it is very possible for, myself and all my friends to not go swimming just because 1/3 is such a small fraction. Next thing I'm going to do is break down what Simon is saying. So that can't be true. I almost never go swimming and neither do any of my friends. So what he's doing, he's identified that himself and his friends don't go swimming, and therefore what's being said in the quoted statement must be false. Now, the first question we have to ask ourselves in this case is, what is Simon actually saying? So what Simon is doing is he's connecting the idea of not going swimming, of him and his friends not going swimming, just because none of the people around him go swimming. Therefore, this must be wrong. So since the people around me don't go swimming, the statement must be false. Now, knowing that, so now what we've done is we figured out what Simon is actually saying. So what his kind of point is. We know what the statement in the box is saying. Our job now to find out the mistake is figure out reasons. Okay, what Simon has noticed is that people around him aren't going swimming. We have to now ask ourselves, what are some reasons why they might not go swimming while other people still might? So again, removing the idea of just because he doesn't swim, no one swims. Obviously, that is incorrect. We're now trying to figure out, why does he not go swimming? Is there a reason specific to him and his friends that shows why that particular group might not swim? Well, a lot of other people do. So let's go through the options. A says Simon may prefer other forms of exercise such as running. While that shows why Simon might not like swimming, does that impact his friends? So again, we're looking for a reason as to why they might not go swimming. While A does cover Simon, it doesn't cover his friends. And keep in mind, Simon just specifically mentioned both himself and his friends don't really go swimming. So we can get rid of A because A doesn't mention his friends. B says swimming may have become more popular in recent years. Straight away, we have to ask ourselves, does that impact whether or not Simon and his friends swim or not? And the answer is very clearly no. Just because something is popular does not mean that everyone has to do it. So we can get rid of B as well, just because of that. And that is because it is clearly irrelevant to the question. Option C says the news report that Simon is watching may be incorrect. Now, while that is possible, it is possible the news report made a mistake. The news report itself is incorrect. Does it answer our question? The question asks us to find which of the following sentences shows that Simon has made a mistake. If the news report made a mistake, that means Simon is actually correct, which is not what we want for this question. So C is incorrect as well, because there's not a mistake that Simon can make. And that leaves us with option D. Now, clearly in a test scenario, if you've eliminated 3 answers and you're someone who generally struggles with timing, I will say straight away circle the last answer and move on, just because it's a trade-off between, I guess, speed and accuracy and how comfortable and confident you are in your answers. Because we're obviously trying to break this down all the way down, I'm going to go through option D as well. Simon may live in an area where there are a few opportunities to go swimming. So very first thing we do is ask ourselves, is that a reason why him and his friends might not go swimming? And the answer is yes, because if he lives in an area where there's not really any place you can go swimming, it makes sense why Simon doesn't go swimming that much, because obviously there's nowhere around him where he can swim. And if his friends live in the same area, now that makes sense for his friends as well, because just for the same reason, if Simon and his friends live in an area where there's no real place to go swimming, they probably won't go swimming very often. The answer is D, and it shows a mistake Simon has made. Okay, let's now move on to question number 6. I'll quickly get rid of all these options here. There we go. Alrighty, question number 6. Staff at a wildlife hospital are building a structure to house sugar gliders. The structure has 3 levels, one for food, one for a water bowl, and one for a hollow log that sugar glider can use as a nest. If the food is on a lower level than the water bowl and the log is higher than the food, which of the following statements must be true? Now, this is a logic-based question. We are trying to figure out, I guess, what the ordering of the food, water, and log are, given that they're all on different levels. Now, all that information actually comes from that last little bit here, because this part of the sentence here is the only part that actually talks about the positions of the different things, so the food, of the water bowl, and the hollow log. What that tells us is, straight away, while there is a lot of stuff going on in this question, once we understand the context, because basically the first paragraph is just background information, we can straight away ignore that first paragraph and focus solely on the second paragraph. Now, we are told that food is on a lower level than the water bowl. So straight away, I would always recommend for logic-based questions, especially ones that involve like ranking or positioning, stuff like that, write it out on paper so you don't forget what's going on. So very first piece of information we have is that food is on a lower level than the water bowl. So we know food will be below the water bowl, WB for water bowl, F for food, and actually we'll just focus on that for now. Now, the very first thing I want to talk about is if food is on lower level than the water bowl, what that also tells us is that the food cannot be at the top, because obviously it is under something else. So it cannot be at the top. We also know that since the food is below the water bowl also cannot be on the bottom, because it is always on top of food at least. There we go. The last thing we know is that the log is higher than food. Now, if the log is higher than food, again, if something is higher than something else, we again know the log cannot be on the bottom. So from that, we know the log fits in either here or here. So this is all the information we have so far. Now what we do is we go through the options to figure out which of these options best fit in with our information. The very first thing says the middle level has the log. Now with that, while it is possible for the middle level to have the log, we cannot say it's true. It must be true because the log can also be at the top above the water bowl. B says the lowest level has the food. Straight away, we can see that we already found out the water bowl cannot be on the bottom because it's above the food. The log is also above the food, meaning that the food must be on the bottom. Therefore, B is the correct answer. So C and D are both incorrect for the same reasons. Well, D is incorrect because because we know the food has to be on the bottom. C is incorrect because we're not sure if the highest level has the water bowl or not. Because again, we're not sure which one's higher, the log or the water bowl. We've never been told any information comparing the two. Therefore, the answer leaves only B. Okay, moving on to question number 7. John is collecting a set of toy robots based on his favorite television program. The robots come in different colors, and John still needs the red and green robots to complete his set. So straight away, I'm going to make a note because the question tells us specifically what kind of robots we're looking for, red and green. The local shop has an offer where they will sell any of the following packs of robots, of 3 robots for $10. So we have 4 packs, 1, 2, 3, and 4, and each of the packs contains 3 robots of different colors. Now, at the end, we are told John has a friend who has a spare green robot and will swap it for a pink robot. What that tells us is now, originally, before reading that part, we knew that John needed either a red or a green robot. What this statement here does is shows that if John ends up getting his hands on a pink robot, he can swap it out for a green, which means we're happy if John gets either red, green, or pink. So straight away we know that there are 2 types of toys, I'm going to say. The first type is the ones where John needs to buy that toy no matter what. And that is going to be the red toy because he has no other way of getting it except for buying it in a pack. The other choice, which is obviously green, which is the one he needs, he actually has a choice. He can buy either, that is the wrong spelling of buy either green or, because again, if he gets the green from the pack, that's great. He has both. If he gets red and green, that's great. He has both of the robots he already needs. But of course, if he doesn't get green, he can get pink instead. So essentially it boils into 2 things. He can either get red and green or red and pink. So our job is now figure out which pack has either red and green or red and pink. Straight away, pack 1 has red but does not have green or pink, so we can get rid of that. Pack 2 has red and pink. We know that works. Pack 3 has green and pink but no red, and we know he needs red, so we can get rid of 3 as well. And 4 does not have red either. Therefore, the answer must be pack 2. Okay, everyone, let's move on to question number 8 now. A scientist, Melanie, is trying to figure out why the number of fish in a nearby lake has decreased over the past year. So Melanie states the lake has become more polluted over the last year as well, so it must be the pollution that's causing many fish in the lake to die. So the first thing we're going to do is figure out what is Melanie saying based on the information. So the information correlates the idea of a lot of fish have died. So we're going to quickly make a note of that. Fish are dying. What Melanie is saying is she's giving a reason for the fish dying. So because she's noticed that the lake is becoming more polluted, she's saying that because we've seen an increase in pollution and an increase of fish dying, they must be related. So her main claim is going to be pollution leads to fish dying. So if we're trying to figure out where she made a mistake, we are clearly, well, essentially there's 2 ways we can go. Either we can show that pollution does not lead to fish dying, so showing why pollution didn't actually impact anything. Or another thing we can do is, since Melanie is saying that the pollution is the reason, we can actually also show that she's wrong by showing that there might be another reason why fish is dying, an alternate reason as to why fish should be dying in the lake. So let's look at the options. A says the number of fish in other lakes might not have increased. Do we really care about other lakes? The answer is not really, because again, we're only looking at the pollution in this lake and the fish dying in this lake. So A is straight away incorrect because it is irrelevant. B says pollution may also cause health problems in humans. The question we ask ourselves is, do we care about humans? Also, no, we are specifically talking about the impact of pollution on fish. So B is wrong as well. C says the number of plants in the lake might not have decreased. For the exact same reason as B, we can get rid of C as well, because again, we do not care about plants, we are caring about the fish, leaving only the answer D as our correct option. More people may have fished from the lake over the past year, and what D is doing is showing another reason why fish have been dying out from the lake, because if a lot of people are fishing more from that lake, obviously it means there are less fish left over, which would also be a reason as to why the population has decreased. Okay, everyone, let's move on to question number 9 now. Okay, I've gotten a message that you guys want me to go through question 6 again. So what I'll do is I'll probably get up to the halfway point, and then we'll start going to the questions you guys want me to re-explain. So like I was saying, question number 9, some students are growing flowering plants by different windows in their school and keeping track of when they bloom. The students put the geranium in the canteen and the guppy plant in the music room. The wax plant they chose to the school hall blossomed before the guppy plant, but after the bromeliad in the library. The geranium bloomed on the same day as the plant in the school hall. One of the plants bloomed the day before any of the others. Which one was it? Now, the very first thing we have to do is, obviously, we know there are 2 main parts to this question, which is number 1, the types of plants. So we are told 4 different types of plants. The geranium, so I'll underline those. So the geranium, the guppy plant, the wax plant, and the bromeliad, and the 4 different locations they are at, which is the canteen, the music room, the school hall, and the library. The very first thing I'm going to do is actually write out the different plants and where they are. So we're told the canteen, so we'll have the locations in the first row. So canteen, music room, we'll call it MR, school hall, SH, and the library. So in the canteen, we are told specifically that the geranium is there. So right, geranium underneath canteen. In the music room, we are told it's the guppy plant. In the school hall, we are told it's the wax plant. And the library, we know, has the bromeliad. So we're trying to figure out which plant bloomed a day before any of the others. So now, once we've got this information, The reason we draw it out is so we don't have to keep reading over the lines, because it's a lot easier to get mixed up on, I guess, sentences and and big worded problems than it is to do on something that's written out clearly. So it's very good to actually write out the information in a almost like a table format, just so it's very easy to look over when you're solving the question. So now what we're going to do is focus solely on the timings of when they bloom. So we're told the wax plant, so let me change colors for this real quick. The wax plant bloomed before the guppy plant, but after the bromeliad. So we know bromeliad is going to be before the wax plant, and the wax plant is going to be before guppy plant. So we'll go early to late in our ranking. So far we know bromeliad is earliest, wax and guppy are later on. So clearly, actually, let me quickly amend this. We actually don't know what time, or I guess if the guppy or the wax plant bloomed first. So I'm actually going to write them next to each other because we haven't heard about any information comparing them. So honestly speaking, straight away from this, we can actually tell what the answer is. The answer has to be the bromeliad. The reason behind that is because we are told only one of the plants bloomed the day before any of the others, which means all the other plants must be later on. So, but just in case, we'll keep going through it because of course we still want to break down the rest of this question. The only one we haven't looked at is the geranium blooming on the same day as the plant at school hall. We know the geranium, this plant at school hall was the wax plant. So we know wax plant and the geranium must be together. Sorry, everyone. I just noticed in the question, it does specify the guppy plant was after the wax plant. So that doesn't actually change how we answer the question, but it does give us a more, I guess, accurate overview of what the rankings are. So we know from that information, what we've compiled is that the wax and geranium are together. The bromeliad is before both of those, and the guppy is after both of those, meaning the plant that bloomed the day before any of the others must be the bromeliad because it's the only one that bloomed early. All right, let's move on to question number 10 and go to question number 10. The 16 shapes in set 2 shown below should be identical to the shapes shown in set 1. How many of the shapes in set 2 are not identical? So very straightforward question, and while it might seem like it takes a long time, I would say the best strategy here is to just methodically start in set 1, go shape by shape and compare it to the shapes in set 2. So what I like to do to keep track, what I'll do, obviously in the test you guys don't have to do this, but what I'll do so you guys know which shape we're looking at is I'm going to label them. So we'll start with shape A here. So what we're going to do is starting from the top left corner in set 1, I'm now going to go through each of these shapes in set 2 until I find a match. So we know obviously in the first row, no matches. Second row, first shape not a match, but the second shape is here a match right over there. So I'm going to label this as A as well. So I'm going to quickly also draw a border around the shapes that do have a match. Actually, sorry, I should do the other way. What I'm going to do is I'm going to label the shapes that do have a match. And for the shapes that don't have a match, what I'll do is I'll draw a border around them so we know clearly at the end how many we have to count. Let's take a look at shape B. So looking for a kind of a diamond shape. In row 1, we can see nothing like that there. In row 2, still nothing. Row 3, nothing there either. And row 4, still nothing. Which means B is a shape that only exists in set 1 and not in set 2. I'm going to circle that so I know to count it later. Let's look at shape I'm going to label the C. So again, comparing. So looking at C, in row 1, I can't see anything because it looks like an arrow. Row 2, still nothing. But in row 3, I can see straight away the shape is stored over there. Let's look at shape number D now. So same deal. We can see shape D is in the second row, first shape there. So I'm going to speed up a little bit just because I think you guys get the idea now. If we look at shape E, I can quickly scan through and see that shape E does not exist. I'm going to circle that. Shape F, same deal if you scan through, does not exist. Shape G, same deal, still doesn't exist. Shape H, going through, we can see it exists in the bottom right corner. Shape I, we can see it exists in the top right corner. Shape J, we can see exists in the first row, third shape. Shape K exists in the last shape of row 2. Shape L, which is a double box, exists in the bottom row. M, which is like a big cross, exists in the third row, second last shape. N, if we scan through, does not exist. Shape O, which is a big L shape, exists over here. And finally, the 3 kind of rectangles stuck together, we know P exists as the first shape in the entire set. So straight away, once we've done that, so what again, just repeating what the strategy was, we just went through literally shape by shape and compared them to the set. And what another thing I'll do is basically I'll just cross out the shapes as you go. So for example, in shape A, if we identify A, it's actually good to cross it out. In this case, I use the letters instead. So when I'm checking for later shapes, I only need to check the shapes that haven't been marked. So idea is finally, once we figured out all the unique shapes, all we have to do is count 1, 2, 3, 4, and 5. The answer must be D, 5 shapes. Let's now move on to question 11. So question 11, a gardener is giving advice about taking care of plants. He says, some people think talking to plants is strange, but it's actually a really good idea. After all, you're more likely to remember to water them if you treat them like friends. Which one of these statements best supports the gardener's claim? So obviously, first thing we're going to do, again, strengthening weakening question, figure out what the main claim is. The main claim is talking to plants is good. So he says right here, it's actually a really good idea. So we know that is what we're going to be looking at. So the claim is going to be, you should talk to plants. And again, to reiterate, if you're struggling with finding out what the main claim actually is, just ask yourself, what is this person trying to make me or someone do? In this case, they actually the gardener is actually trying to make us talk to our plants more. So we know that is going to be the main claim. So once we know what the main claim is. The second thing, so previously when we talked about strengthening and weakening questions, I talked about the idea that the way the paragraph is structured is there is a main claim and the rest is something called reasoning or explanation as to why his claim is good or true. So next question we ask ourselves is why? So why should we talk to our plants? And if you read through the paragraph, it says in the last sentence, after all, you're more likely to remember to water them if you treat them like friends. In other words, you're more likely to take better care of them. So you are more likely to take better care of them if you talk to them. So knowing that, we are now going to go through 4 options. So A says people often notice details about a plant's health when they're talking to it. Questions we have to ask ourselves, number 1, does it give a reason as to why, I guess, talking to your plants is good? The answer is yes, because you notice more details. Now, keep in mind, just noticing more details doesn't straight away prove that it's good or not. But what it does do is it, I guess, provides evidence for what the gardener has already said. Because of what the gardener has said is that you're more likely to take better care of them. What we know is that if you notice more details, you know what to fix. That falls directly in line with what the gardener is saying. So A does sound like it would be the correct answer. Now let's look at B. Some people believe that plants can understand what people say to them. Now, when you break down a strengthening question, there are generally 2 ways an option can strengthen a claim. The first way is providing a new piece of, I guess, a new argument or a new piece of reasoning. So another reason as to why they're correct. The second type is going to be proving that what they've said is true. So like I said earlier, the paragraph is structured into a claim and to reasoning. The second type, what it does is it gives an example of the reasoning being true in real life. The question we ask ourselves, does B do either of those? And the answer is no. When B says some people believe that plants can understand what people say to them, we have to ask ourselves, does believing that plants can understand what you're saying say anything about I guess, taking better care of them or that talking to them is a good thing? The answer is no, because we don't know how the plants react. We know they understand, we don't know how it impacts them. So B is wrong as well, because we want to know clearly, is it a good impact or a bad impact? And just understanding isn't enough information to make that distinction. Option C says talking to plants won't help people avoid overwatering them. Now, this is actually saying a bad thing about talking to plants. It's saying that it doesn't help. So C is definitely wrong, because we want to say something that supports the gardener's claim that talking to plants is a good thing. And finally, D, talking to plants is very old tradition. This is very irrelevant, because tradition, a lot of things are tradition, it doesn't actually say anything about whether it's a good thing or not. Just because something is traditional doesn't mean that it's beneficial. So D is wrong as well, leaving us with A as the correct answer. Let's go to question number 12. 4 friends are in a car together. There are 2 seats in the front and 2 in the back. Caitlin is either driving or sitting beside Talia. Talia is sitting behind the driver. Jimmy is not sitting in the back, and he's not sitting beside Andrea. The very first thing I'm going to do is actually going to draw out the 4 car seats. So we know the way it's structured is we have 2 seats at the front and 2 seats at the back. And I'll quickly label these. The front row is obviously going to be called the front. The second row is going to be called the back. And we'll label this seat here as the driver's seat, just because it honestly doesn't matter which seat at the front you label the driver's seat, but just because normally driver is in the front right seat, we'll start with that. Now, the very first thing I want to do is read through the paragraph and see what information I'm given as to where they might be sitting. So the very first thing we see is that Kaylin is either driving or sitting next to Talia. Now, that's not enough information for us to start somewhere, because we don't know exactly where someone is. The second sentence, however, Talia is sitting behind the driver. Straight away, that tells us Talia must be in the back right seat, because again, we chose the front right as the drivers, and Talia has to be behind the driver. So that gives us a very good starting point. Now, moving on, Jimmy is not sitting in the back, and he's not sitting beside Andrea. Now, if he's not sitting in the back, that means Jimmy must be obviously in the front row. We don't know where, but we know he's either here or here. The more important thing is that he is not sitting beside Andrea. If Jimmy's in the front row and there's only 2 seats in the front row, if Andrea can't sit next to Jimmy, that means Andrea cannot be in the front row, because no matter which seat Jimmy's sitting in the front, if Andrea is also in the front, she'll end up next to him, which means Andrea must actually be in the back row with Talia. So we've now filled in 2 of our boxes. I'm going to jump back to the front. Kaylin is either driving or sitting beside Talia. Straight away, is it possible for Kaylin to be sitting next to Talia now? No, because we already know that seat is taken up by Andrea, meaning that Kaylin must go for the second option, which is driving. So Kaylin must be driving, leaving behind only 1 spot for Jimmy. And we know, therefore, Caitlin is the driver. So I guess the main strategy I want to talk about here is the idea of having a clear starting point. If you guys started off like literally line by line and started off by trying to figure out, different possibilities with Caitlin and Talia, you would actually end up wasting time, because you have to draw out 2 different configurations, which obviously is a waste of time in a timed exam. So what I'll recommend is actually scanning through the question, take that extra 5 seconds to finish reading the question to see if it gives you a very distinct starting point, which they did with Talia in this case. And that will let you only focus on one solution rather than having to juggle 2 different solutions. Alrighty, question 13. In a word game, players must make words out of letters. Each letter has a value that is a whole number that is at least 1. So it's a whole number, at least 1, which means the smallest possible score is 1, and we can't have any decimals or fraction scores. The score for the word is the total of all the values of the letters in that word. So for example, TOO scores 4. meaning that T plus O equals to 4. Now, I'm going to focus on this first statement for a second. Now, we know T plus O equals 4. Now, if we think back to the information they started or the rules they gave us, being that each letter is a whole number value that is at least 1. So 1 is the absolute minimum. Straight away, we know O and O are both the same number, so they must be the same value. What numbers can O be? If the total of O plus T must be 4, we know that straight away. O, we are looking at only 1, 2, and 3 as our possible values. Now, let's take a look at 3 for a second. If O is 3, we have O plus O, that'd be 6, which is already bigger than 4. So straight away, you can also say 3 is not possible. If O is 2, you get 2 plus 2, which is also 4, which means T must be 0 for the whole thing to add to 4. So we can get rid of 2 as well, meaning that straight away, we figured out that O must have a value of 1. So I'm going to write that on the side, O equals to 1. So the point of doing that is straight away, the more specific information we get, the easier our life is going to be later on. So I know O is 1, and that lets me straight away figure out what T is as well. Because if I know O is 1 and O plus T equals to 4, we know that T plus 1 equals to 4 essentially. Or T plus 2 equals to 4. In other words, T must equal to 2, because obviously 2 plus 2 equals 4. So I'm going to write that on the side as well. So we've now figured out everything we can in statement 1. Let's move on to statement 2. The word TWO scores 6. Now we already know that O and T are 1 and 2. So I'll write T. So T plus W plus O, and I'm actually going to label which statement we're looking at. In statement 2, T plus W plus O equals to 6. Now we know T is 2. We know O is 1, which means 2 plus W plus 1 equals 6. Obviously 2 and 1 make 3. And for W plus 3 to be 6, W must be 3. So we now know that W is 3. Let's now move into statement number 3. The word hoot also scores a 6. So clearly H plus O plus T equals to 6. Straight away, without even substituting all the different values in, I already know from the first statement that T plus O equals to 4. If T plus O equals to 4, that means O plus T, which is the same thing, just shuffled around, must also equal to 4, which means H plus 4 equals to 6 or H equals to 2. Now, the only letter we're missing because at the end, we want to figure out, T plus H plus A plus W. The only thing we're missing is now A. So we're now going to focus on the last line, statement number 4. We know T plus H plus A plus T equals to 7. Now, already we figured out that T is 2, H is 2 as well. We don't know A yet, and T is 2 again, equals to 7. So 2 plus 2 plus 2 equals to 7. So 2 plus 2 plus 2 plus A equals to 7. So A plus 6 equals to 7 in other words, and therefore A must equal to 1. So far, we've actually found out all the different possible values of all the different letters. Once we know that, it's very easy. All we have to do is add T, H, A, and W together to find Thor. So the final, thing we're going to do is T plus H plus A plus W. And I'll put this in a little box here so we don't mix up with everything else. We know T is 2. We know H is going to be 2. We know A is 1. And we know that W is 3. So essentially, Thor is just going to be 2 plus 2 plus 1 plus 3, which is, of course, 8. Sorry about that. Let's now move on to question 14. Ilika wants to buy a sandwich. He's currently waiting in queue at the sliced bread Sangers. Ilika says, sliced bread Sangers always takes 15 minutes to make my favorite sandwich. But the loafing around bakery down the road always takes 10 minutes. It takes less than 5 minutes to walk there. So I should be heading to loafing around and I'll get my sandwich sooner. Now, first things first, we're going to figure out what Ilika's logic actually is. Now, Ilika is obviously talking about the idea of going to a place that does it faster. So we know that Ilika's main priority is going to be time. So I'm going to make a quick note of that. So Ilika's only real concern that he's mentioned is time. So we'll keep that in the back of our heads for now. So from that, what is he saying? So he's saying that he should go to loafing around instead of sliced Sangers. The question being, why is he changing shops? Obviously for a shorter time, because his logic is that if you compare the 15 minutes it takes at sliced bread Sangers with the 10 plus 5 minutes of walking, theoretically, less than 5. If it's 10 plus less than 5, we know it's going to be less than 15, which is why Ilika is saying he should change shops. So he's saying that change shops for a faster sandwich or for a shorter wait. So what we've done is firstly, we've now established that Ilika's main concern is time and that Ilika's logic is that he should change shops because there'll be a shorter wait. If we want to prove that Ilika has shown a mistake or identify what the mistake is, we need to find something that essentially shows that it's not actually a shorter wait. Because again, the only reason he's changing shops is because he thinks the wait is shorter. So for him to be wrong, we have to find out why it would actually take longer if you change shops. So let's take a look. A says sliced bread sandwiches make a better sandwich. At no point does Ilika talk about liking one sandwich better than the others. So A is wrong because it's not relevant to his main concern, which is time. B says sliced bread sandwiches may have a wider range of sandwiches. Again, his only concern is time. We don't care what kind of sandwiches they serve. We don't care how good those sandwiches are. We only care about how long he has to wait for his food. So B is wrong as well. For the exact same reason, C is wrong because C talks about the cost and we only care about the time. Therefore, the answer must be D. And to, of course, to double check, we have to ask ourselves, does D show a reason why he might be waiting longer if he changes? And the answer is yes, because D says the queue at loafing around may be longer than the one at sliced bread Sangers. Now, obviously, obviously a long queue means you're waiting longer. So even if making the sandwich takes 10 minutes and walking there takes less than 5 minutes, if the wait time is 30 minutes, either way, he's going to be waiting around for a much longer time. Therefore, D shows that he is incorrect. Let's move on to question 15. All right, question 15. May and Kira's class is due to go on an excursion to an observatory so they can look at stars through the big telescope. The only children in the class who are not going on the excursion are the ones who need to play in the soccer match. So straight away, first thing I notice is that the statement clearly says only children in the class, or the only children in the class who are not going are the ones who need to play in the soccer match, which means basically we can summarize all that information down to one very simple statement. If you don't play soccer, you must go to the observatory. So once we know that very simple statement, we can now answer the question. So Malion says May does not play soccer, so she must be going to the observatory. Does that fall in line with our statement we've made? Yes, it does, because again, if the only reason you can skip the observatory is if you play soccer, if you don't play soccer, you have to go. So Malion is correct. Since May does not play soccer, she has to go to the observatory. Robin says Kira is not going to the observatory, so she must be playing in the soccer match. And Robin is also correct for the exact same reason, because again, there is only one reason in the entire universe, or as described in this question, where you would not go to the observatory, which is if you play soccer. And since Kira is not going, we know that she must be playing soccer. The answer is C, both Malion and Robin. So we'll now move on to the second half of the paper. So down all the way down to question 16. So Anna, Nina, Veronica, and Timur sit at a square table, which is 4 wooden blocks arranged at its top. The types of block are shown below. So here we have, before I actually begin talking about what the shapes are, I want to start by talking about the main strategy we go through. So in this case, if you're looking at views from above, or bird's eye views, as you guys might have learned it's called, generally the best thing to do is as you go through the different solids there are, or different shapes there are, identify, I guess, the features that are going to show up on a bird's eye. So what can you see? Think about what you'll be able to see when you look on top. So straight away, the first shape has a smaller circle and a larger circle. And obviously, if something is smaller and larger, if you look from the top, you'll actually see, I guess, the smaller one first and the larger one as like a circle around. So no, in a bird's eye view, it's going to look like a circle with a slightly bigger circle around it, which clearly we know is going to be this one right over here. So I'm actually going to label the shapes A, B, C, D, and this is clearly going to be shape number A, or shape A, I guess. B is a cube, and very clearly from the top, a cube is always going to be a square, just because obviously every side of a cube is a square. So this will very clearly be shape B. Shape C is a cylinder, and as we all know, from the top, a cylinder looks like a circle. So the circle will be shape C, and shape D is a cone. And now the special feature of a cone is that it has a pointed tip, which looks basically like a dot if you look from above. So we know that is going to be shape D because it has a dot in the middle. So now we know exactly where all the shapes are. We can now actually look at the question. So one of the friends has the following view. On the left, they will see shape A clearly because we can see the smaller and the larger bits here. And this is probably going to be shape number B because it has a square. Now, it is possible for it to be shape C as well, because if you guys realize, a cylinder with a side view actually looks like a rectangle as well. The second shape that is shown is going to be the cube. That's actually not always going to be the case, because cylinder, if you look at it from the side, also looks like a square. So we'll actually ignore that second shape for now and focus only on shape A. If the friend has this exact view, we know that the shape A must be on the left. Okay, so what I'm going to do is now I'm going to quickly go back over the original diagram. I'll redraw the shape, redraw the labels. So B, A, C, and D. And I'm going to actually say where the left and right is for each person. Starting from Veronica, obviously Veronica is facing this way. So left will be here and right will be here. Nina is facing this way. So left will be here, right will be here. Anna is facing this way. So left will be here, right will be here. And Timur is facing this way. So his left will actually be over here and his right will actually be over here. So what we want to know is who has shape A on their left. So straight away, shape A, obviously the only people that's going to see it are going to be Nina and Timur because they're the only ones viewing that side. So we can see it straight away, get rid of Anna and Veronica. So if you look at Nina sees shape A, but it's actually on Nina's right, which means Nina cannot have it on the left. Therefore, the answer must be Timur, because if you look at Timur, his left shape is indeed shape A. And again, as we've already identified, shape A is on the left of the view, meaning Timur is the correct answer. Okay, let's move on to question 17. To win a soccer match, you have to score more goals than the other team. Grand Valley High School plays soccer in a competition with a group of other schools. They are awarded points for winning and drawing matches, but no points for losing. The team with the most points at the end of the season comes top of the competition. Now, straight away, starting from the first statement, to win a soccer match, you have to score more goals. We know there is only one way to win, which is score more goals. If you tie, you don't win, you draw. If you don't score, I guess, if you score less goals, you lose. And another thing you have to know is that if the only way to win a soccer match is by scoring more goals, and that's important because the statement at the end says, at the end of the season, Grand Valley High School has sadly failed to score a single goal, which means, in other words, Grand Valley never won a match. Because how can you score more goals if you don't score any goals in the first place? So knowing that, which of the following must be true, let's take a look. If you break down the idea of Grand Valley never winning a match, keep in mind that doesn't mean they always lose, because drawing also counts as not winning. It is possible that Grand Valley still drew every match by going 0-0. So we'll take a look and see what that tells us. So A says Grand Valley High School came bottom of the competition. Is that always the case? Because we're looking for must also be true. So in other words, which of the options is always the case? Now, if Grand Valley High School doesn't score a single goal, do they have to come last? And that is not true, because what we are told in the paragraph is that you get points for winning and drawing. And obviously the top is going to be, or your ranking in the competition is going to be how many points you have. Now, it is possible for Grand Valley High School to not come last if they draw every match, because what happens if, I guess, another team wins one match but loses every single other match? Because we don't know exactly how many points you get for winning versus drawing, it is still possible for Grand Valley to still beat that other team despite never winning. So A is definitely wrong, because we're looking forward to the following must be true. So A doesn't always have to be true. So A is wrong. B says Grand Valley High School lost more matches than any other teams. Also not true, because it is very possible for Grand Valley High School to literally draw every single game they played. So I'm going to make a note of that. Could draw every match. C says Grand Valley High School won fewer matches than any other teams. That is technically, I guess, so I can see why a lot of people might think this is true, because straight away we already know for a fact that Grand Valley can't win. So obviously their number one matches is actually 0. And straight away you might think to yourselves, okay, if Grand Valley High School won 0 matches, then they must have won fewer matches than any other team. So C must be correct. But that's actually not true, because the idea is, what if they tied? What if there are other teams that also score 0 matches? The wording of this problem is very important in this case, because it says then any of the other teams, which means every single other team. So if there are 10 teams in the competition, nine teams, excluding Grand Valley, must have scored one more games. But that's not true at all, because Grand Valley can tie. There can be multiple schools that have 0 wins. Therefore, the answer is actually D. Grand Valley High School failed to win any matches, which you know for a fact is true, because it is impossible to win if you're not scoring goals, because the only way to win is to score more goals. The answer must therefore be D. Let's move on to question 18. The students in Tani's class must choose either Jacob or Nicole to represent the class in the school chess competition. So we have exactly 2 choices, Jacob or Nicole. Jacob won 3 of his last 14 games in chess club, not a very good record. Nicole won 11 of the last 12 games in chess club, an excellent record. Now, knowing that Tani is now saying Nicole has won a higher fraction of the recent games of the club, which is true, so she must be the better player. She should represent our class. So straight away, like we did with the other questions of this time, we're going to break down her logic first. So Tani's logic is essentially, because Nicole won more, she must be better. So higher win rate, or actually more wins, I guess is a better way to put it, equals to better player. This is what Nicole is saying. Oh, sorry, Tani is saying, I meant. In order for us to show why Tani, or how Tani has made a mistake, we have to show why that might not be the case. In what situations does more wins not mean you're a better player? And that's what we're going to ask ourselves each time we look at an option. So A says there may be another player in the class who's better than Nicole. This actually doesn't matter. A is irrelevant to the question, because again, we only have 2 choices, Jacob or Nicole. Regardless of how good other people are, we're only choosing between Jacob and Nicole. So it doesn't matter if there is someone else who is better. They can never be picked, because it literally says they must choose either Jacob and Nicole. So A is wrong. B says Jacob might have played against better opponents in the games. Now, is that a reason why Nicole might have more wins but be a worse player? And it absolutely is. If Nicole is playing against complete beginners the entire time, it makes sense that even if she's not very good, an amateur player could still win a lot of games. But if Jacob is playing against very, very good players, very strong players the whole time, even if Jacob is still very good, he might be, it explains why he's losing a lot. So B shows a clear reason as to why Nicole won more games, but might not necessarily be a better player. So we'll put a tick next to B, because that sounds like the correct answer. And C says Nicole has not played as many games as Jacob. While that is true, the number of games is very comparable, 14 and 2. And even if Nicole played 2 more games, it's impossible for her to win less than Jacob. So C actually does not change the outcome at all. And finally, D, they may have played lots of other games at the chess club. We don't really care about what's going on after the chess club. We only know it in that sense. Sorry, D doesn't actually provide us any definite information, or any information that will tell us who is better or who is worse. So D is wrong as well. The answer must be B. Let's move on to question 19. In a school for young magicians, the weekly timetable is as follows. So Monday, Tuesday, Wednesday, Thursday, and we have different classes at different times. So the young magicians need their magic wands for 3 classes: spells, charms, and herbs. There are no classes on Fridays. So this is very important. This week, the classes on Wednesday, there you go. So no classes on Fridays. This week, the classes on Wednesday are due to competition. This is the important part. Classes on Wednesdays are cancelled due to competition. Now, the question itself is asking how many classes did the young magicians need the ones this week? Straight away, if the classes on Wednesday are having cancelled, we can immediately get rid of the Wednesday column. So I want to actually cross that out, because we don't need it at all. So how many classes do the young magicians need their wands for this week? We know that they're only going on Monday, Tuesday, and Thursday. We know that the only classes they need the wands for are going to be spells, charms, and herbs. So what we're going to do is basically count the number of times spells, charms, and herbs turns up in the remaining days. So on Monday, we can see we have spells. That's 1. On Tuesday, we can see we have charms and herbs. That's 2 more. On Thursday, we can see there are herbs. So 1, 2, 3, 4 classes altogether where they're going to need their magic wands. Question 20. Chris is taking is making a sandwich for her younger sister Sally. Sally knows that Chris likes puzzles, so she challenges him to arrange the 4 ingredients in the sandwich in a specific way. She tells him the lettuce must not touch the mayonnaise, the cheese must not touch the lettuce, and the mayonnaise must go directly on top of the chicken. Now, straight away, just like we did with the whole driving seat question, start with a clear starting point, something you know for a fact. So the most, I guess, accurate information we have, or the most specific information we have, is that the mayonnaise must be exactly on top of the chicken. So in any given ranking, so if there are 4 ingredients, like 1, 2, 3, 4, mayo and chicken must be on top of each other. So there are 3 different possibilities. So mayo and chicken coming first and second and third, or third and fourth. Once we've established that, now we can fill in the rest. The only other piece of information we have is that the lettuce must not touch the mayonnaise and the cheese must not touch the lettuce. So here's the thing. Let's look at the first possible configuration. We are told that cheese and lettuce cannot touch. What that means is that they must be separated in the order of the sandwich. In order for them separated, there has to be something between them, right? But if you look at the first and last configurations, the only 2 options left are together, which means cheese and lettuce cannot be in those configurations because, again, they can't touch, they can't be next to each other. That tells us the only possible configuration is with mayo and chicken being in the middle, because now the first and fourth places are clearly separated, meaning that cheese and lettuce can go in very comfortably without touching. For us to figure out exactly which one is on the top, which one is on the bottom, we now look at the last piece of information. The lettuce must not touch their mayonnaise. Since mayonnaise is second in this case, lettuce cannot touch it, so lettuce must be last. Therefore, the only option left is going to be cheese, because that's the only ingredient we have in place so far. Therefore, the answer is A, cheese is at the top. Moving on to question 21. A vet is talking about baby animals. She says, in the case of wild animals, it's best to avoid touching them. For kitten, puppies, and other pets at home, careful handling is important to make sure they're developing properly. Now, we're looking for the statement that best supports the best claim. There are actually 2 main claims going on here. The first claim is going to be, if it's a wild animal, leave it alone. Do not touch wild animals. So 1, don't touch wild animals, because she clearly says avoid touching them. The second claim is for kittens, puppies, and other pets. So for pets, careful handling is important. So you should be touching them. So you should be carefully handling them because it's important to make sure they're developing properly because it's good for them. So now, of course, just like we said earlier, to find out if the statement is supporting, we have to either see if the statement provides a new reason as to why the claims are true or shows why what they said is correct. Now, in this case, the unique thing about this paragraph is that it doesn't actually provide any explanation. You'll notice that it only has the only, stuff or information provided in the statement are those 2 claims, no reasoning whatsoever, which means we are only looking for something that shows why it's a good thing or why the claims are a good thing. So for claim number 1, it gives us the reason as to why touching wild animals is bad for you, or why you shouldn't touch wild animals, or number 2, why you should be handling your pets and kittens, etc. So knowing that, as we go through each option, we're going to basically check, does that option fit one of those 2 claims? So A says some people have pets at home that will want to wild animals. Does that give us a reason as to why we shouldn't touch wild animals? No. Does it show us why we should touch our pets? Also no. So A is definitely wrong because it doesn't fit in with either of the claims. B says handling puppies and kittens often helps them be less afraid of people. So this does talk about handling puppies and kittens. So we're looking at claim number 2. Does it show us why we should be handling them? Yes, it does, because it shows us that they become less afraid of people, which is a good thing for them. So B is indeed supporting. C says many people help wild animals by putting out food and water. Is it saying why we shouldn't handle wild animals? No. So C is wrong as well. And we know we're only talking about wild animals because it mentions wild animals in the option. And finally, D says handling puppies and kittens is something many people enjoy doing. Does it give us a reason as to why we should be handling them? A lot of you guys might think yes, because it does say, people enjoy it, therefore we should do it. But keep in mind, the vet talks about the idea of why it's good for the pets themselves, not for people, for the pets. D is only talking about why it's good for people, which is why D is actually not correct. The answer is therefore B. Let's now move on to question 22. A wall is decorated using a set of identical tiles, but some of the tiles were rotated before being added to the wall. A section of the wall made up of 4 complete tiles is shown below. Keep in mind the 4 complete tiles are identical, which means they have to fit together perfectly. Now, if you guys look very carefully, if we, kind of divide this up, we can see that it's basically a 6x6 square, which means the only real way for identical squares to be stacked together is basically if you stick them together as such, into quarters like this. Once we've established that fact, and we know that this is the only real way to fit together 4 identical tiles, this question becomes very, very straightforward. Which of the following could be the design of each of the tiles? All you have to do is look at each of the options and figure out which of these is what's shown in the original diagram. So very clearly it's going to be A, because straight away we can notice it has the 3 black diamonds in a row plus the 1 in the corner, which is exactly what is going on here. Straight away the answer is A. So obviously, in some cases the answer might not be as obvious as it is in this case, in which case you would actually have to break down you'd actually have to look at each of the options individually to see where it doesn't work. work. So yeah, I think we'll now move on to question 23. Scroll down a little bit. Yep. Peter needs to return a book to Fiona, but he will not see it today. However, he knows that the following meetings will happen. Now we are told straight away, Peter needs to give a book to Fiona, but he's not going to see her today, meaning that he needs to somehow get it to Fiona without ever meeting her. So we are told the following meetings happen. Peter will meet Zhang at 9 o'clock. Sam will meet Tim at 10. Tim will meet Ursula at 11. Ursula will meet Fiona at 12. Now, if these meetings happen, what we understand is that Peter can now get the book to Fiona by passing it to people he meets and they pass it along, etc. So we kind of know generally what the question is looking at. The idea of what, I guess, chain of people would allow Peter to have the book end up with Fiona. So which of one of the following meetings would enable Fiona to receive the book today? So we have option A, Fiona will meet Sam. B, Fiona will meet Tim. C, Zhang will meet Tim. And D, Zhang will meet Ursula. The very first thing I want to do is note that none of these actually mention Peter. So there is no way for Peter to get an additional meeting. Now, in the original four pieces of information given to us, only one of them has a meeting with Peter. The first one, Peter will meet Zhang at 9 o'clock. So if Peter we meet Zhang is the only meeting stated in the original piece of information, and none of the options say anything about Peter, we know that the book must go to Zhang first. So number one, since Peter only meets Zhang, Zhang needs to pass the book along. Because we know that, we're now only going to focus on Zhang and see what happens. So who does Zhang meet? You'll notice that in the rest of these, Zhang is not mentioned. So it's not possible currently for Zhang to meet Fiona, which means what Zhang needs to do is meet someone else who will meet Fiona. Straight away, we know A and B are wrong because they do not mention Zhang. And again, since Zhang only had that one meeting with Peter, he needs an additional meeting to be able to pass it on to someone else. So A and B are straight away wrong. We're now looking between Tim and Ursula. Now, here's the thing. We know that Tim meets Ursula and Ursula meets Fiona. So technically speaking, both people will be able to give it to Fiona at some point. If knowing the person Zhang's meeting isn't enough to answer the question, now we have to look at the times. We see that Zhang meets Ursula at 12:30. However, in the original statements, Ursula meets Fiona at 12 o'clock. So if Zhang meets Ursula at 12:30, he's going to be too late because the meeting with Fiona has already happened. Ursula has no way of giving the book to Fiona now because Fiona's already left. Therefore, the answer must be C. Zhang will meet Tim at 10:30 because what will happen is Peter will give the book to Zhang at 9 o'clock. Zhang will meet Tim at 10:30. And then Tim will meet Ursula at 11, and then Ursula will meet Fiona at 12. So the final pattern looks something like this. So Peter passes to Zhang, who passes it off to Tim, who passes it off to Ursula, and finally it gets along to Fiona. And you notice the times all make sense because Peter and Zhang happen at 9 o'clock. Tim and Ursula meet at 11. Oh, sorry, Zhang and Tim meet at 10:30. Tim and Ursula meet at 11, and finally Ursula and Fiona meet at 12. And you'll see that all these times fall in order, meaning that this is definitely possible. Therefore, the answer is C. Let's move on to question 24. Last winter, Mr. Murray planted 20 crocus plants, but only 5 of them grew. After some research, Mr. Murray found that there were 2 possible reasons for this. Reason number 1, the winter may have been too warm as crocuses need cold weather to grow. And reason number 2, possums may have dug up the crocus plants for food before they could fully grow. So there are 2 reasons that it's possible, or that might explain why only 5 out of 20 grew. Now, Mr. Murray says, I checked the weather reports and the average temperature in the winter was indeed higher than normal. That must be a reason why so many of the crocuses didn't grow, so I shouldn't blame the possums. Now, straight away, the question we have to see, I think as we read through this, we can now understand what Mr. Murray's logic is. Mr. Murray says, there are 2 reasons, and I've proven that one of them happened. Therefore, that must be the one reason. So in this case, the 2 ways my plants could be affected were the warm weather or the possums digging up crocus plants. Since I know the weather is warm, therefore that must be the correct answer. The issue with that clearly is that does there always have to be only one reason? Just because it's warm, are the possums now going to ignore the crocus plants? That is not true at all. Therefore, that is what we're looking at. And what you'll notice is that A straight away says that crocuses may have also been affected by the possums. So essentially, we're answering the question just like we did with every other question of this type. We're answering the question, is there another reason, which A provides? The other reason is, yes, both can happen together. If we look at the rest of them, B says the warm winter may have allowed possums to find other food sources. Does that show that it's a mistake? It doesn't. It's actually agreeing with what Mr. Murray is saying, because what Mr. Murray's argument overall is that because it's warm, the possums didn't eat it, the warm weather was the issue. And what B does is it shows that, yes, the possums actually didn't eat the crocuses at all, therefore it was only the warmer winter. So B is definitely wrong, because it agrees with what Mr. Murray is saying. C says possums may also like to eat other flowering plants. Again, C is agreeing with Mr. Murray, shows a reason as to why the possums left the plants alone, which is the opposite of what we want. And again, same with D, possums may only dig up crocus plants if they cannot find anything else. Because what that implies is that the possums found something else, which again agrees with Mr. Murray. And again, we want to identify the mistake is made, and B, C, and D do not do that. So knowing that, the answer is therefore A. So let's move on to question 25. So I think 25 was definitely one of the trickier questions in the paper. It definitely involves a lot of estimation, which can be very difficult. In the diagrams, the following 4 diagrams show pairs of objects. So in the first picture, we have a house and a car. Second picture, dinosaur and a person. Third picture, a tree and a swing. And finally, a truck and a shed. So for the objects in each pair, the scale is the same, which means basically the diagrams are to scale. If you got a ruler and basically compared it, you'll kind of have a good sense of how big each thing is. Now we are told specifically the height of the car is 1.5 meters. So I'm going to make a label right here. That is going to be 1.5. The person is 2 meters. That is going to be 2 meters. The swing is 2.5 meters. And finally, the shed is 3 meters. Now, my recommendation for this question, because we're trying to figure out which of the following is the tallest: dinosaur, house, tree, truck. In other words, the larger thing in each pair. While we can't directly compare each of the larger things to each other, because again, different scales for different diagrams, what we can do is get an estimate of how tall each thing is by comparing it to the other thing in the same diagram. For example, in diagram 1, we have the car and the house. If you guys make a diagram, or if you guys make notes and kind of have a quick look at roughly how big the house is in comparison to the car, you can see it's roughly a little bit less than 4 times. So I'm going to make a note. House is around 4 times the car. And since we know the car is 1.5, that is 1.5 times 4, or roughly 6 meters. The house is roughly 6 meters tall. We can then do the same thing for the other 3 diagrams. So the man is 2 meters tall. So roughly the dinosaur in comparison is roughly, I would say, 3 times the amount. So the dino around 3 times person. Since we know the person is 2, that'll be 2 times 3, which is around 6. The tree, if you guys do the same thing, is roughly 1, 2, 3, 4, and 5. Or actually, 1. Sorry, I think my scale's a little bit off there. So I'll quickly redo that to make it a little bit neater. 1, 2, 3, and 4. Yeah, so roughly 4. The tree is around 4 times the swing. That's going to be 2.5 times 4, which is going to be 10, obviously. And finally, just from looking, we can kind of tell truck is a little bit more than maybe 2.5 times the shed, which is going to be 2.5 times 3, or roughly 7.5 meters. Once we've done all the calculations, we now have a general idea of how tall each of the things are. Now, these aren't entirely accurate. Obviously, we didn't get a ruler and measure it. We just estimated. But that estimation is good enough because now we can notice that the differences are actually quite big. 10 meters is actually a very significant difference from 7 and 6 meters, which means that the tree is clearly the tallest thing. And obviously, the answer is C. Let's now move on to question 26. During a science lesson, the teacher says the most effective way to reduce water waste at home is to make sure the taps are not leaking. Now, straight away, again, it's our supporting / weakening the claim question. First thing we're going to do is figure out what the claim is. And the claim is that the best way to reduce water, best way of, well, let's say saving water, just to save on space, is stopping leaky taps, or making sure the taps aren't leaking. Now, this is essentially what the teacher is saying, what the teacher's actual claim is. You'll notice this is pretty much everything that's said. There is no real reasoning, which means in order to figure out an option that best supports the teacher's claim, we simply have to find which of the following gives us a reason as to why leaking taps or stopping leaking taps is the best way of saving water. So A says a huge amount of water is wasted in people's homes every year. Does this say why fixing leaky taps is the best? No, it doesn't actually mention leaky taps at all. So A is definitely wrong. B says it's very easy to fix taps that are leaking. Now, the question then becomes, how do we define what is best? Obviously, if we're talking about the most effective way to reduce water waste, it's what saves the most water. B talks about the fact that the taps are easy to fix. Now, obviously, being easy to fix does not mean you save the most water, which means B does not give a reason as to why leaky taps are the best way of reducing water waste. So B is wrong as well. C says leaking taps are the biggest source of water waste in the households. Now, C does in fact show why leaking taps, or fixing leaky taps, is an effective way of reducing water, because it is the biggest source of water waste, which means obviously stopping it will eliminate the biggest source of water waste. In other words, it will make it clearly the best way of reducing water waste overall. Therefore, the answer is C. Quickly, we'll run over D as well. There are many different ways to reduce water waste at home. D is very clearly incorrect as well, because it never says anything about which one is best. While it does introduce the idea of there being multiple different ways to fix water waste, it never says which one is best, which is what the teacher is talking about. We want clearly to understand which option, or which method, I guess, is the best at reducing water waste, which D does not do. Therefore, the answer is very clearly C. I think we now move on to question 27. Idris is trying to solve a puzzle. He has 4 boxes labeled W, X, Y, and Z. He knows that there is a different amount of treasure in each box, and he has 4 clues at the box where the 4th clue is not shown. So clue 1 says box X contains more treasure than box Z. So I'm actually going to start off by getting a preliminary understanding of how they compare with each other. So we'll obviously label it from most to least. So we'll say most at the top, least at the bottom. We know that X has more than Z, so X must be closer to the top and Z must be be closer to the bottom. Clue 2, W contains more treasure than Y. We're not entirely sure about where W and Y are just yet, so we'll leave that for now. And clue 3, W contains more than X. So we know W must be closer to the top than X is, and now the only thing we're missing is obviously Y. We know clearly where W, X, and Z are relative to each other. We now have to figure out where Y is. Yeah. So after reading all 4 clues, Idris is able to put the chest in order of how much treasure they contain. Now this is an important one. Since we know that the only thing we're unsure of is box Y, we know for a fact that whatever option lets us figure out the final rankings must talk about box Y as well. Straight away, that eliminates option C, because C does not mention Y at all. Now let's go from the bottom and just check out the rest of the options. Box Y contains more options than box Z. Does it help us? Not really. The only thing we know about Y is that Y has to be basically below W. Now, we don't know if that's second, third, or fourth. What C does is says it contains more than Z. We know it can't be bottom, we can't be least anymore, but we don't know if it has more or less treasure than X. So C doesn't give enough information, so it's wrong. Sorry, not C. Talking about D, sorry. Yeah, D doesn't give us enough information, so D is wrong as well. Now let's look at B. B says box X contains more treasure than the box Y. Now, again, there are 3 positions where Y can be as of right now, here, here, and here. So between W and X, between X and Z, or after Z. If X contains more treasure in the box Y, straight away we know that it can't be between W and X, but it has to be less than X. But do we know where it is below X? We do not. We don't know if it's between X and Z, and we don't know if it's at the bottom, meaning that it doesn't give us enough information to have a complete understanding of where everything is. So for the same reason as D, B is wrong as well. And that leaves us with A as the only answer possible, because if we look at A, and obviously in the real exam, in general, I recommend checking the options going from top to bottom. A would be the one to check first in this case, in the actual exam. Box Y contains more treasure than box X. So straight away, we know it has to be above box X, right? So if we know W, X, and Z is in this position, from most to least, we know that Y has to be above X. However, we also know from clue 2, Y is below W. So it clearly gives us that Y is between W and X, giving us the final, ordering of W, Y, X, Z from most to least. Therefore, A is the correct answer. Okay, let's move on to question 28. An unusual dice is labeled such that the number of dots on opposing faces add up to 5. One of the faces has no dots. No 2 faces have the same number of dots as each other, which diagram shows a possible view of the dice. Now, straight away, if we know that every face is unique, so they all have a different number of faces, 0, 1, 2, 3, 4, and 5, we know that essentially, and we know that the ones opposite each other have to add up to 5. We have to think to ourselves, how does the net of a cube work? In general, if the opposite sides in a cube cannot be seen from the same perspective, because obviously you can only see one or the other. They're on complete opposite sides, which means our strategy now is to figure out, okay, in order to figure out which views are possible, which views are not possible, we have to figure out, is there any of the options where the opposite sides are shown together? So let's take a look. A has 2, 5, and 0. Remember, the rule for opposite sides is that they add up to 5. Do any 2 of these 3 sides add up to 5? And the answer is clearly yes. The top side is 5, the blank side is 0, and they add to 5, therefore they must be opposite. And again, from our understanding of how nets of cubes work, if 2 sides are opposite, they cannot be seen together, so A is incorrect. B has 5, 1, and 3. So again, same strategy. Do any 2 of these three sides add up to 5? And the answer is no, because 5 plus 3 is 8, 5 plus 1 is 6, 3 plus 1 is 4. So B is definitely a possible view of the dice. C, same rule. We can see that C is incorrect because 1 and 4 add up to 5, meaning they must be opposite again. And of course, if they're opposite, cannot be seen together, C is incorrect. And for the exact same reason, D is incorrect as well, because 3 and 2 add up to 5. And again, because of that, they should be opposite and should not be shown together in a perspective, leaving us with B as the only correct answer. Question 29. Anyone who loves musicals will love the new animated musical Karimba. Tina says Connor adores Karimba, so that tells me he's a big fan of musicals. Now, in general, if you pay careful attention to the wording of the advertisement, anyone who loves musicals will love the new animated musical Karimba. Saying that everyone who loves musicals loves Karimba is not the same as saying everyone who loves Karimba loves musicals. For a more, relatable example of the same logic, it'd be the same thing as saying that everyone who plays soccer plays a sport, which is true because soccer is a sport. But does that mean that everyone who plays a sport plays soccer? That is absolutely not true. There are a lot of other different sports you can play. That's the same logic here. Again, just because anyone who loves musicals loves Karimba, it does not mean that someone who loves Karimba has to love musicals. So that's exactly what we're going to look at. So which of the following sentences show that Tina has made a mistake? Karimba may have won an award for best musical. Now, does winning an award for best musical tell us anything about who likes it and who doesn't like it? No, it doesn't. Remember, our main focus in this question is going to be, is Connor a fan of musicals? Does Connor like musicals or not? Since A doesn't give us any information about the people who like musicals, A is irrelevant. B says Karimba may appeal to people who normally don't like musicals. Now, B, I would say, could very much be the correct answer in this case, because again, it relates the idea of people and Karimba and the idea of liking musicals. Because what Tina is saying is that Connor likes musicals, therefore he likes, Connor likes Karimba, therefore he likes musicals. What B is saying is No, that's not true. You can like karimba, but you might not like musicals normally. The B could definitely be the correct answer because it shows that Tina is wrong. C, karimba may be Connor's favorite movie. Just because karimba is Connor's favorite movie, it does not mean he likes musicals. Says nothing about whether he likes musicals or not. So C is definitely wrong as well because again, it is irrelevant. And finally, D, karimba may have changed the kind of things Connor likes to watch. We don't know what he likes to watch normally, so we of course don't know what he likes to watch after. So D just doesn't give us enough information to make any kind of judgment. Therefore, the answer must be B. So anyways, question 30. In the first round of a tennis competition, every player plays 5 matches. To qualify for the second round, a player must win at least 4 of their matches. Darren and Monaro have both won all their first 3 matches. They are about to play each other. There are no draws in tennis. So Alyssa says at least one of Darren and Monaro will qualify for the second round. To figure out if she's correct or not, we have to first figure out what the winnings look like so far. So here's the thing. Let's say if we divide into rounds, first round, second round, third, fourth, and fifth, because there are 5 matches. We know that both Darren and Monaro will split into a table. They have won the first 3 matches. So they are each now at 3 wins. Now we know to qualify for the second round, you have to win at least 4 matches. Now in the fourth round, where they are now playing each other, obviously there has to be 1 winner and 1 loser. And regardless of who wins and who loses, that means one of them, either Darren or Monaro, will get that 1 extra win, which will bring them to 4 matches, which means that they will indeed qualify for the second round. So Alyssa is correct. One of them will get that extra win, bringing them to the 4 wins necessary to qualify. And of course, it doesn't matter who it is because they're both tied up to that moment. Next, Emily says Darren and Monaro can't both qualify for the second round. Is that possible, or is she true? Let's take a look. So there are basically, we know for a fact that one will lose, one will win. It doesn't really matter who wins and who loses. So let's for now say that Darren wins and Monaro loses. Darren now has 4 wins and has qualified. What Emily is saying is that since Darren has qualified, Monaro cannot qualify. But is that true? Not at all. Because there is a final match he can play, which means as long as Monaro wins the match afterwards, he can still qualify for the second round, meaning that only Alyssa is correct. So I think that pretty much wraps it up. Again, I do want to apologize that it took so long. I think just from the manner of the questions, while the questions themselves aren't super difficult, they do have a lot of logic behind them, which is why I ended up taking a little bit longer. Thank you everyone so much for sticking around for all of this. If there are no other questions, you guys can head off, and obviously good luck. I do want to remind everyone again that we do have this was a Think Skills paper. We do have the math paper and the reading paper lined up for the next couple of weeks. So please stay tuned for that. We'll have other tutors who definitely specialize in those topics covering those for you guys. So look forward to that. And again, that's it for today.